Hey, welcome to Quick Chemistry. Today we're diving into the electrifying world of acids and bases. Fast, furious, and full of surprises. Let's break it down in just 4 minutes. First up, what about their properties with respect to electrons? In the Lewis model, acids are electron pair acceptors, while bases are electron pair donors. Think of it as a cosmic game of tug-of-war. Bases generously donate electrons, and acids happily accept them, forging bonds that drive countless reactions. For example, when ammonia, a Lewis base, donates its lone pair to a proton, a Lewis acid, you get an ammonium ion. Now let's talk strength. Among acids, strong ones like hydrochloric acid, HCl, dissociate nearly 100% in water, releasing tons of H+ ions. On the flip side, weak acids like acetic acid, CH3Cu, only partially dissociate. Similarly, strong bases such as sodium hydroxide, NaOH, provide complete OH ion liberation, while weak bases like ammonia, NH3, only do so to a lesser degree. This difference in ionization is key to predicting their behavior in reactions. What are aromatic carboxylic acids? Simply put, they're acids where the carboxyl group is directly attached to an aromatic ring. Take benzoic acid, also known as benzene carboxylic acid or carboxybenzene for instance. Because of the electron delocalizing power of the benzene ring, these acids are generally milder than many mineral acids. Their unique structure also lends them stabilizing resonance, tweaking their acidity in fascinating ways. Ever wonder why salts of weak acids pop up as food preservatives? Consider sodium benzoate, the salt form of benzoic acid. Converting a weak acid into its salt form boosts its water solubility and stability, ensuring it evenly disperses in foods. Plus, its antimicrobial action targets spoilage microbes without compromising taste. That's why so many fruit juices and condiments rely on these benzoate preservatives. Next, let's revisit Lewis acids and bases from another angle. Remember, in Lewis terms, acids like boron trifluoride, BF3, and even H+ ions eagerly accept electron pairs, while bases such as hydroxide, OH, or ammonia, NH3, donate electrons. And when a proton shifts from an acid to a base, you form a pair known as conjugate acid and conjugate base. For example, HCl loses a proton to become Cl, its conjugate base. Simple yet essential. How do acids and bases affect common indicators? Here's the lowdown. Blue litmus turns red in the presence of an acid, while red litmus flips to blue when met with a base. Methyl orange appears red in acidic solutions and shifts to yellow as the solution turns basic. Phenolphthalein stays colorless in acid, but blossoms into a vibrant pink under basic conditions. And yes, litmus paper is derived from natural dyes extracted from lichens, nature's own chemical indicator. Let's quickly look at some everyday acids. Malic acid is found in apples, giving them their tang. Tartaric acid abounds in grapes and wine, lending that signature sour bite. Oxalic acid is present in leafy greens like spinach and even in rhubarb. And speaking of neutralizing acidity, antacids like milk of magnesia are used to soothe an overacidic stomach by neutralizing excess acid and restoring balance. Ever wonder why bases are key in making soap? In saponification, a strong base such as sodium hydroxide reacts with fats, triglycerides, to split off fatty acids. These fatty acids then form their sodium salts, your everyday soap. Without the base, the transformation from oily fat to cleansing soap simply wouldn't happen. Now, a quick word on lactic acid and citric acid. Lactic acid is what gives sour milk, yogurt, and even some fermented foods their sharp taste. Citric acid, abundant in citrus fruits like lemons and oranges, is not only a flavor booster, but also a vital preservative in beverages and other foods. And finally, what is Aqua Regia? Translated as royal water, Aqua Regia is a powerful mixture of concentrated nitric acid and hydrochloric acid in a common ratio of 1:3. This deadly cocktail dissolves noble metals like gold and platinum, thanks to the unique way the acids work together. Nitric acid oxidizes the metal, while hydrochloric acid provides chloride ions to form soluble metal complexes. Before we wrap up, here's a bonus quick thought. Although acids and bases seem like opposites, they share some intriguing similarities. Both can react violently with metals to liberate hydrogen gas, and extra care is necessary since many of their reactions, like neutralization, are exothermic, releasing heat in dramatic fashion. That's your 4-minute extreme rundown of acids and bases. From electron dynamics to food preservatives, soap making to Aqua Regia. Stay curious, keep experimenting, and until next time, let the reaction spark your interest.